Welcome to today's discussion on the
I've been asked in to help with the gravity science experiment. Measuring Jupiter's gravity depends on measuring changes in the spacecraft velocities that goes around Jupiter. What we're looking at is for variations in that acceleration rate that tells us something about the change in the gravitational field of Jupiter as it gets closer to the surface associated with a mass structure inside. And so what we're trying to do then is measure the spacecraft's velocity as a function of time very, very accurately. And we do that by measuring the Doppler shift of the radio signal. So if you've ever heard a fire engine going by with its siren, as it's approaching you, it's high pitch, and when it goes by, it goes, right? That Doppler shift, that change in pitch tells you about the velocity of the fire engine relative to you. So the instrument that we use is sort of a combination of the listening on the ground to the radio signal and the radio signal transmitted by the spacecraft. So the biggest part of the instrument, of course, is a 34-meter diameter radio antenna at Goldstone, California. Then on the spacecraft, there's a high-gain antenna that's pointed at the Earth. So the radio instrument measures the voltage coming in from the antenna from the Earth, and then it transmits a voltage that goes fed out to the radio signal to send back to the Earth. And then the gravity measurement tells us something about density variations, which then can tell us something about whether there's storms on the outside or whether they penetrate all the way through, and whether there's some hint of a structure at the center other than just compressed gas of the hydrogen.
One of the most exciting aspects of weather is a thunderstorm. So what happens on Jupiter? We know that lightning occurs on Jupiter. The Galileo orbiter made images of lightning on the night side of Jupiter. And these lightning bolts are hundreds of times more powerful than lightning on the Earth. In a way, this is surprising because Jupiter gets less sunlight, less energy from the sun than the Earth does because it's much farther from the sun. With Juno, we want to understand the structure of these thunderstorms. We want to understand where these parcels begin to rise, how much water is in them, how they're organized, are they larger than terrestrial thunderstorms, and why it actually has thunderstorms and super lightning. Juno will be able to tell us that.